end of this video, you will be able to make a piston head part and a crankshaft assembly using the latest CREO 7 software. You will also be able to run a kinematic analysis of the same assembly and an engineering drawing like this. We upload videos every week, so please subscribe, like to support us, and don't forget to hit that bell icon to never miss an update. Open CREO. This is the window that is visible. In the right hand most corner, we have different options like the help, the PTC support, and the search. Let's start with the help. When we click on it, we will be directed to the PTC support link. This happens only when we have an internet connection. Here we have different help tutorials and information about the new CREO Parametric 7. There's also introduction, and different exercises as well. In the support, we'll be directed to the PTC Learning connector. Again, this happens only when we have an internet connection in the system. Next is the search bar, where we can do a command search. An example is shown here. We can hide the bars. Here we have the play trail file. If we have a file, a trail file, we can open it. Right now we don't. Also, applications are connected in this particular option. The next option is the settings options. Here we have the CREO parametric settings. As an example, we'll try to change the window color from light to dark. We can also change other colors and other settings here. Model display is how your model is going to be displayed in the part or assembly sections. If you want to save it in your config file, you can say yes. Right now we are going to say no. You can also select the working directory. It is very important to do this step before starting with CREO. You can open an existing file. You can also preview it. Right now we have a table. By selecting it, we are also previewing it at the same time. If you select all files, other files like SolidWorks or any other file will be visible. New is selected in order to direct to the different options we have, like sketch, part, assembly, and so on. You can choose your file name, the description, and select OK. Right now we are going to cancel this option. In the bottommost corners, we have full screen. We have the browser where it opens the browser. Again, internet connection is necessary for this. The model tree can be hidden or made visible. We have folder browser. We have favorites if any favorites are selected. This option in the bottommost right corner is not visible because we haven't opened any part or assembly. It will be activated when we do so. Shortcut keys for open is in the top corners, and also a shortcut key for new is available. Create a new assembly. Type in the new file name. Deselect the default template option and select the units to be used. Middle-click the mouse button and hover the mouse in order to reorient the planes. Select Sketch, select the plane, and sketch. Reorient the plane. Draw the sketch, specify the dimensions, click the OK button to exit the sketcher. Extrude. After selecting the sketch in the model tree, specify the depth, click OK to exit. In order to remove the material with simple geometries, we can use extrude. In order to do that, first select sketch, select the plane where the sketch needs to be done. Click on sketch view to reorient. Select circle and draw a circle. Specify the dimension. Click OK. Now with the selected sketch, click on extrude. Select remove material. To a certain depth, specify the units. Click OK. In order to create a round feature, select the round from the engineering options in the model tab. Select round and select the edge where round feature needs to be created. Specify the radius. preview the round feature. In order to preview, click on this button. If satisfactory, click OK in order to exit the round feature. As you can see in the model tree, a round feature is created. In order to create the datum axis, let us start with the default orientation. Select the plane display. Select plane in order to create the datum plane. After selecting the plane, select translation and specify the value. You can also rename it to a desired specification and click OK. The datum plane is created. Now let us create a datum axis. Select axis. Here select the planes which will define this axis. We are going to select the created plane and the front plane. The axis has been created and as can be seen in the model tree. If we need to edit this axis, click Edit Definition. Here we are going to rename it and click OK. As you can see in the model tree, the axis has been renamed. In order to create a sketch, click on Sketch, select the plane where the sketch needs to be created, click Sketch View to reorient. Now select References in order to create reference axes. Once references are created, select Line to create a drawing. Start your sketch by clicking on the lines. In order to exit the line command, middle click the button in your mouse. Specify the dimensions. Type in the dimensions as shown. If specific dimensions are need to be created, select the dimension in the Sketch tab. Select the lines. Exit the dimension by middle clicking in the mouse. Similarly, specify the angles and type in the values. Select OK to exit the sketch. If the sketch needs to be changed, You can always do so by clicking dimensions and changing them. In order to create a fillet, select the sketch view. In the sketch, select two edges after selecting the fillet option. Specify the radius. We will do the same thing with the other two edges and specify the radius. Now we're going to select the whole sketch and mirror it. Above the reference line. Exit the sketch. Fillet and mirror options have been created. We will try to extrude the sketch using the extrude to next command. Select extrude. Instead of extruding to depth, we will select extrude to next. Under options, select side 1 and side 2. In the side 2, select to next. As you can see, the extrude is on both sides now. Preview the extrude and click OK. Using wireframe, you can visualize the extrude. We are going to create a new extrude using the previous sketch. We have the sketch here, which was previously created. Now we'll go to the extrude option. In the placement tab, click define. Use previous. Now we are taken to the sketch mode. Where we have the previous sketch. Click on offset. Use loop in order to select the whole sketch in a loop. Specify the offset dimension. Click close. Delete one of the lines by just right-clicking and selecting delete. Project it by selecting the line to be projected to. You can corner we can mirror the sketch by selecting all the lines. Ensure that it is a continuous selection. Once the sketch has been selected, select the axis through which the sketch has to be mirrored. Click OK to exit the sketch. We are going to extrude the sketches and create extrude to next with both the sides specified. Click on remove material. Select both the sides and specify the depth. Preview it. If it is satisfactory, click OK. We are going to create a sketch on a surface in the part model. Display the plane. Click on sketch. Select the surface as a reference. Create center lines. The center lines are created for reference. Choose rectangle. Create a rectangle in the sketch. Choose rectangle by corner. Specify the dimensions. Select a circle. Coincide it with the edges of the rectangle. Choose delete segment to delete the segments in the circle and the rectangle. Click OK if satisfied with the result. Extrude to next. Specify the side 1 and side 2. Click OK. We are going to extrude the sketch with extrude to next command. After selection of both the sides, click OK. Now we are going to extrude from a surface in the body. Select the surface and select sketch. Click on sketch view to reorient. Create center lines. Draw a rectangle. Input the dimensions. Click OK. Remove material. Input the depth. We're going to sketch and extrude through an intersecting part model. Select sketch, choose the references, sketch view to reorient, click on circle and create a circle. As you can see, the sketch intersects with the part model. Click OK and extrude. Specify the depth. Click OK. We're going to be using the hole command in the model tab. Click on the hole command. Click on the surface where the hole needs to be created. Select the direction. Specify the depth of the hole. Ensure the hole type is correct. Click for both sides. Specify the diameter of the hole. And click OK. The round feature can be created for the part with multiple selections. Here we have the edges where we want to create the round feature. We're going to select the round feature from the model tab. Here we are going to add 5 as the radius. Select the edges where the round feature needs to be created. Multiple selections can be made by clicking on the control button. Once the selections are done, you can preview it. Click OK if you are satisfied with the result. Highlight the plane. Select Sketching from the Model tab. Choose the right plane. Pick the sketch view. Create 2 center lines. Choose rectangle. Sketch it by clicking the mouse button and dragging it to the point where you want the rectangle to be created. The dimensions as 48 and 1.7. If you do not want this dimension, you can choose the dimensions by clicking on the edges where you want the dimension and middle click in the mouse. If everything's as per the dimension, click the OK button. Exit the sketcher. Now we are going to revolve. As default, the center line is taken as the axis for rotation, so we will create another center line. We're going to edit the sketch, create a center line in the sketch view. Click the OK button to exit the sketcher. Now revolve. Choose the center line that we have created. Remove material. Click the OK button. We have revolved feature which removed the material from the piston head part. We're going to be patterning the revolve feature. Click pattern, select direction and select the axis. So the pattern is going to be along the direction of the axis. Select the spacing, enter the number of instances that's going to be created. Click OK. Now we are going to extrude on a specific surface. Click Sketch and select the surface. Sketch view to reorient. Create center lines for reference. Select circle and specify the diameter. Click OK and extrude. Remove material and specify the depth. Select the extrude to depth. Preview the extrude and click OK. Select round and select the edge. Specify the radius and click Preview and then OK. In order to open the part in CREO, first array is not displayed. To erase the files which are not displayed, select the working directory. Here we're going to select exercise number 2 folder as the working directory. Open, select the part and click open. The crankshaft part is opened. In the model tree, you can see the different features, groups that are created in the part. We are going to create a pattern of the extrude feature. To do that, select the extrude feature, right click and select pattern. We want a pattern along the direction of the crankshaft. So select direction, choose the axis, specify the spacing and the number of members. Flip the direction if it's not appropriate. Click OK. To create a chamfer on an edge, click chamfer, select the edge where the chamfer is needed, specify the dimension, click OK. As you can see in the model tree, the chamfer feature is created. You can edit it or delete it if it's not correct. We're going to create another one. Click on the edge where you want to chamfer, preview the result and click OK. We are going to create a hole on this surface. Select hole. On the surface, click, drag and drop to get the references. We're going to drag on this plane. Specify the dimension. Here we are going to coincide with one plane, and the perpendicular plane we are going to specify a dimension. Type in the dimension of the hole. The diameter being 9. Extend to next surface. If satisfactory, click OK. Right click on the whole extrude. Click pattern. In the pattern, we're going to select axis. Select the axis about which the holes needs to be created. The angle between the holes and the number of members needs to be specified. Click OK. As you can see, 6 holes have been created. Erase the not displayed parts from the memory by clicking on the Erase Not Displayed. Select the working directory. You can either open the assembly from an existing file or create a new one. Select assembly, type the name, the description of the assembly, deselect the default option and click OK. Select the measurement units, either mm or inches, in absolute or relative. Type the description, which will be displayed in the parameters. Click OK. You can see the description you typed and the model by in the parameters. Assemble. Select the part. In user defined, choose default, which places the model in the default position. Click OK. Open the next part. Choose cylindrical constraint. Select the cylindrical faces. If the assembly is not satisfactory, you can edit it by clicking on the part and edit definition. We're going to place the pin in the middle. So select the planes and coincide them. It can also be done by distance and typing in the value. Open the next part. Select the cylindrical faces and coincide. Orient it by selecting angle offset. In order to do that, select the planes and define the angle. Similarly, the next O-ring can be assembled. Similarly, assemble the next ring. Click OK. Now we are going to see how we can use the layer tree and the tree filters. You can see the model tree. Here, if we unhide all the datum planes and axes, these are visible. In tree filters, apply and OK. So now if you check the model tree, you can see all the features that were used. Let's hide them. Go to the tree filter, unhide and apply an OK. So now the features are hidden. Let's unhide them again. Let's check the layer tree. In the layer tree, we can select the different axes, planes that were used while creation of the model. In order to select multiple selections, click Ctrl and then make the selections. Once your selections are done, you can hide them. Right click and hide. Let's return to the model tree. We will open a SolidWorks part. In order to do that, click on New, select Assembly, type the file name, here we are naming it as Connecting Rod Assembly. We can write a common description about the part. Uncheck the Use Template. And we're going to select units as millimeters. In description, type the description, and you can type your name in model by. Click OK. Click on Assemble. Here it's important to select SolidWorks parts or assemblies. Open the SolidWorks part. As you can see in the model tree, the features are not displayed as it is a SolidWorks assembly. Click on Assembly, type in the file name, uncheck the Use Default Template. We will select millimeters as the unit. Now we'll display the axis and the plane. Click on Datum Plane, select the plane, translate it, you can see in the model tree that a new datum plane has been created. Go to Pattern, and here we're going to select the direction. Select the plane along which you need the pattern to be created. Choose the number of instances and the spacing. As you can see, the datum plane has been patterned along the direction of the selected plane. We will create axis on these datum planes. So click Axis, select the datum plane where the axis needs to be created. As you can see, at the intersection of the two planes, the axis has been created. Let's create another one. Let's select this plane and this plane. Again, it's created perpendicular to the first axis that we have created. Similarly, we have created another axis. We can create a pattern using the pre-existing pattern, that is the pattern in the memory. Directly click the axis and create the pattern with the pre-existing pattern as shown. We're going to add an assembly now. Click on Assemble. We're going to select the part which we want to add. We have added the part. As soon as we add it, we have to provide the constraints. There are different constraints in CREO, which can be seen here. And there's user defined. For now, let's select pin, which means that the crankshaft is going to rotate about an axis. For that, we have to specify the axis where we want the rotation. Let's select these two axes. We also provide translation. so that the connecting rod is fixed along the axis direction. We'll select this plane and the right plane. Click OK to exit. We'll assemble this piston head in the crankshaft. Before we do that, let's flip the crankshaft. Go to placement, click on the constraint and then flip. Click OK to exit. Let's assemble the piston head now. Edit definition, position where we want to, and we're going to provide the slider constraint. Select slider. We have selected the axis. Now let's align the planes. We are going to align it with the datum plane. Repeat can be used to create multiple part assemblies. Select the constraints and add. Now these constraints are copied. We just have to specify the assembly constraints. So we want this axis and this plane. Let's make the next selection, another one, and so on. As you can see, it's a very quick process to create assemblies with similar constraints. Once satisfactory, click OK. As you can see in the model tree, multiple piston parts have been assembled using the same constraint. Let's assemble a connecting rod. Select all files to view other format files like SolidWorks parts and assemblies. Click on the assembly, open. We're going to select pin constraint for this portion of the connecting rod and the piston head. Select the surface. For translation, select the planes. Now we'll connect the bottom portion of the connecting rod with the crankshaft. For that, create a new set with the constraint changed to cylinder. Now select this surface with this surface of the connecting rod and crankshaft. Click OK to exit. Select the connecting rod, click repeat to create multiple assemblies. Select the constraints. Before selecting the constraints, make sure that you know which constraints to be selected. Click Ctrl and select all the constraints that were previously selected and add. Now follow the same sequence to create multiple assemblies. Repeat by selecting the surface, plane, and the surface of the crankshaft. If not satisfactory, you can always remove or redo it. We're going to see how we can do that. Delete the selection and redo it. Select the surface, the plane, and then the correct surface. Do the same with the other piston heads and connect them to the crankshaft. Click OK when done with the assembly. You can save the assembly once satisfactory. One or creating a new one. Here we're going to create a new one. We're going to specify the new name. Untick the default template option. Click OK. Browse for the model. We're going to use the piston part. Click Open. And right now we are going to use empty with format. Browse for the format. These are the standard formats available in Creo. We're going to select one and open. As you can see, it's empty. Click on General View to open the model. We have the isometric view as default. We're going to change it to front plane. In the drawing view, we're going to select solid or no hidden and solid. To project the view, click on projection view, drag and drop. We're going to do the same drawing view for the projected view. To project on the side, click, drag and click again. Double click on the view. Select sections and add a section. Click on plane. And select the view. Apply and OK. As you can see, a section AA about the plane selected has been created. To create a detailed view, click Detail View and select a corner or an edge. Draw a spline around it. You can drag by unlocking the view. As you can see, a detailed view has been created. We can position it by dragging and dropping it. We're going to create another view. And position it. We can dimension it by going to the Annotate tab. Select the dimensions that are desired and drag to position them. You can dimension the radius as well. Zoom in to dimension the detailed parts. Right click on the dimension and select the options like Move to View. If in case we want fractional, we can select fractional. We can flip the dimension arrows as shown. Create a new drawing. Type in the new name. Untick the default template, empty with format, browse for the form. Using system formats, select a form and open. Browse for the model. Here we will be using the crankshaft assembly model. Open. In the general view, combine state as no, and then click on screen. You can set the custom scale based on the size required. Let's make it a little larger. So double click on the view, go to scale, under custom scale, enter the value. Let's make it 0.25, apply. You can see the reps under view states. View display, you can see the different display environment. Click OK. Let's open the model. You can see you can toggle between the drawing and the model from this drop down. You can click on exploded view to see the exploded view. You can edit the positions. Here it looks a little odd, so let's move this. To make the exploded view a little more clear. Position. And click on this empty screen to exit the position. Let's create a new rep. Select the items needed from the checklist. Close. We have created a rep for the item shown in the screen. Click OK to exit the exploded view. Now let's create a new orientation. Go to Reorient, select Dynamic Orient. Here we can specify the angles needed. Let's call this view as ISO. Save it. So the current view in the screen has been saved. Let's see the front view. Let's go back to the ISO view. Let's toggle back to the drawing. Select ISO view. Select view states. Now we have the ISO state which we had created earlier. So our view is ISO view, and the state, the rep we are using is the ISO rep. We can untick it to not explode the view. Go to tables, table from a file. Under system tables, let's select one. Let's move the note. We can change the width by the height width option. Move the table. Ensure that the table tab is activated when you're doing so. Again, width can be changed by selecting the column or a row in case of height, and then click OK. You can wrap the text. You can increase the height by selecting the row. You can create balloons by selecting the table and the view. We can edit the balloons by clicking on them and edit definition. Select the new selection and click cancel.
Analysis with animation like this. We upload videos every week, so subscribe to be updated and hit that like button to show us your support.
In the crankshaft assembly, we can check the model tree. And the symbol which you can see right there means that the assembly is not user defined, but with other constraints. We'll go to applications, click on mechanisms. You need to have a license in order to open this application. Select servo motors and select the constraints which were given. Specify the angular velocity. Here we're going to specify as 45 degrees per second. Click OK. Go to Mechanism Analysis. You can rename the analysis definition. Select Type as Kinematic. end time as 12 and run. We can rerun the assembly by overwriting the pre-existing one. Click OK. In Mechanisms, open Measure Results, Measure Definition, type the new name, select the pin connection, apply and OK. Similarly, repeat. In the measure results, select all the selections that are being done, that is V1, V2, V3. View the graph. Here we can visualize the kinematics motions. The graph is plotted with measure against time. Playback to view the animations. We can animate the motion by clicking play and adjust the speed in the speed toggle. Let's try it with a different speed. So pause the motion. Let's go back to the beginning and let's increase the speed a little more this time. Play. And you can see the graph on the right hand side. It shows the measure versus time at different instances. If needed, we can also save this animation. Right now we are not going to do that.